Radical functions is the name of the game here in the next two sections. The most simplest type of radical function here lies behind me, y equals the square root of x. A radical function is simply one in which the input variable lies underneath a radical sign. Again, the most simplest one is when an input variable lies underneath a square root sign. We could have a cube root, a fourth root here, and we'll get into those later on, but let's just talk about this example. Y equals the square root of x, where the x is the input variable and y represents the output variable. Let's ask three things here. Number one, the domain, and then the two intercepts for which the graph crosses the vertical axis and the horizontal axis. Let's go after the domain. The domain, remember, is all the possible input values that yield a real number value. So we have to think to ourselves, what are the possible x values here that would yield a real number? Well, certainly 4, 5, any positive x value will yield a real number, but what about others, and what are they? Could x be negative? Well, if I have a negative 2 under there, the square root of negative 2 is not a real number. What about 0? So if I plug in 0 there, I have the square root of 0, which is 0, and so 0 is okay. And so right away we see it's all real numbers greater than or equal to 0. All real numbers greater than or equal to 0. Now we can simply write that in a nice condensed form, so you could say this way, x is greater than or equal to 0. So the graph will exist only for those x values. Let's take a look at the graph. So here I'm in y1, I'm going to go to second x squared, which is the square root, my input variable x, and on a standard window. Let's take a look at that. So here we see the graph only exists for input values of 0 and greater. So I'm going to draw that up here. So here is my graph. So it starts here and goes up, and it continually goes up there. All right, so let's go after the vertical intercept. Remember what that is. That is where the graph crosses the vertical axis, the graph of your function. Well, remember this graph here, it looks like it's starting here, but the easy shortcut method to find this is to replace your input variable with 0 and find out what it equals to. So if I plug in 0 here for my input, I'll get the square root of 0, which happens to be 0. So where this graph crosses the vertical axis is at 0, 0, or the origin. So let's go after the horizontal. Well, the idea is, where does this graph cross the horizontal axis? And it doesn't take much to understand that it crosses it at the origin as well. So this is a special case where the vertical and horizontal are the same.